I request you all, please like my video and share my videos with your friends and colleagues and subscribe my channel if you are not already subscribed. Thank you. We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in the month of July 2024. The question is from the section analysis, and the question is based on the concepts of the functions of several variables. This question is from the part C, which is a multiple select question. There can be more than one answer. It carries 4.75 marks. The question ID is 704068. This question is also suitable for the aspirants of JL, DL, TS set, AP set, IIT JAM and GATE. Right. The given question is define a function f from R square to R, where R is the set of real numbers given by f of x comma y is equal to y into under the square root of x square plus y square whole by x when x not equal to 0 is equal to 0 when x is 0. Which of the following statements are true? We are given 4 options. Option 1, the partial derivative of f with respect to x at the point 0, 0 exists. Option 2, dou f by dou y at 0, 0 exists. Option 3, f is not continuous at the origin. Option 4, f is not differentiable at the origin. We will now discuss the solution of the problem in detail. We are given a function f from R square to R defined by f of x comma y, the ordered pair coming from R square, is equal to y multiplied by under the square root of x square plus y square whole by x when x not equal to 0 is equal to 0 when x is equal to 0. Right. So let's now take the first one. The partial derivative of f with respect to x at the origin. By definition, it is equal to limit h tends to 0 of f of 0 plus h comma 0 minus f of 0 comma 0 by h. That's equal to limit h tends to 0 f at h comma 0 minus f at 0 comma 0. Now, when y is 0, fh0 will be 0. f0 comma 0 is 0 by h as h tends to 0 is 0. So thus the partial derivative of f with respect to x at the origin exists. Therefore, the option 1 is true. Right. Let's now get into the second one. The partial derivative of f with respect to y at the origin is equal to limit k tends to 0 of f of 0 comma 0 plus k minus f at 0 comma 0 by k. That's equal to limit k tends to 0 f of 0 comma k minus f of 0 0 by k. F of 0 comma k, x is 0. So that is 0 minus f of 0 comma 0, 0 by k. Limit k tends to 0 is 0. And thus the partial derivative of f with respect to y at 0 comma 0 exists. Therefore, option 2 is also true. Thus, option 1 is true and option 2 is also true. We continue our discussion in the next slide. Yes, that's our function. And we are left with the options 3 and 4, where option 3 says f is not continuous at 0, 0. So to talk about continuity, we have to first of all find out limit of the function f of x comma y as x comma y tends to 0, 0, whether it exists or not. When it exists, is it equal to the value of the function f of f at 0, 0? That's the question. If it is so, then it will be continuous at 0, 0. So for that, we first find limit of f of x comma y as x comma y tends to 0, 0. And that is equal to limit x comma y tends to 0, 0 of f of x comma y, the function what we have written here. Now let x comma y tend to 0, 0 along the path x is equal to m y power k. Yes, x is equal to m y power k, where k is to be found appropriately. Right. Now let's get into it. This is equal to limit. So everything will be converted in terms of y. Therefore, limit y tends to 0 of y into x square, m square y power 2k plus y square by x, m y power k. Now, under the radical, under the square root, take out y square. So when y square, when it comes out, it will come out as y. There is already y. So limit y tends to 0, y into y under the square root of m square into y to the power of 2k minus 2 plus 1 by m y power k. So y square we will cancel. So limit y tends to 0 under the square root of m square y to the power of 2k minus 2 plus 1 by m y to the power of k minus 2. Now we take k is equal to 2. When k is equal to 2, in the denominator there is no y term, m will remain. In the numerator you will have m square into y to the power of 2 into 2 minus 2, y to the power of 4 minus 2, y square. So under the square root of m square y square plus 1. In the denominator m will remain. As a y tends to 0, it will be 1 by m. So limit y tends to 0 of under the square root of m square y square plus 1 by m when k is equal to 2. So now take the limit, you will get 1 by m along the path x is equal to m y square. And this limit exists, but it depends on 1 by m. As m varies, the limit will vary. So it depends on m and varies from path to path. So the limit depends on m and varies path to path. But what is limit? When the limit, when it exists, is unique. But it is differing from path to path. Therefore, the limit does not exist. Since the limit when exists is unique, limit of f of x comma y as x comma y tends to 0, 0 does not exist. So when the limit does not exist, the continuity will not be there. So now therefore f of x comma y is not continuous at 0, 0 since the limit of f of x comma y as x comma y tends to 0, 0 does not exist. And in option 3, it is given f is not continuous at 0, 0. That's what we got. We have shown also. Therefore, option 3 is true. Agreed. Get into option 4. F is not differentiable at 0, 0. So, assume that f is differentiable at 0, 0. Differentiability always implies continuity. Therefore, f is differentiable at 0, 0 will imply f is continuous at 0, 0. But whereas we have f is not continuous at 0, 0. Therefore, our assumption that f is differentiable at 0, 0 is false. Therefore, our conclusion is f is not differentiable at 0, 0. Now, fourth one, f of x comma y is not differentiable at 0, 0 since f of x comma y is not continuous at 0, 0. Therefore, option 4 is also true. Thus, in this question, all the 4 options are true. So, the answer to this question is option 1, option 2, option 3 and option 4. That is the detailed discussion of the solution of this problem. I am pretty sure that you have understood the solution of this problem. I know that you have been watching my videos. If it is so, please like my video, share my videos with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.